Welcome to The Explainer. Today we're going to pull back the curtain on one of machine learning's coolest ideas, how a machine learns to make decisions. Not because we hand-code a bunch of rules, but because it figures out the logic all by itself, just by looking at examples.
You know, it all kicks off with something you've probably used a million times without even thinking about it. Any flowchart is basically a decision tree. Take this fun one about using emojis. You just answer a series of simple questions, and it guides you to a final answer. That's the core idea, right there. So, in the world of machine learning, we just formalize that idea. We call it a decision tree. It's a really powerful model that takes that same flowchart logic and applies it to data to classify things. And what's great is that you can actually follow the logic. You can see how it's making its choices.
And here's the basic anatomy of any decision tree. It all starts at the top with the root node. That's the very first question. From there, every possible answer takes you down a branch. That branch can lead to another question, an internal node, or it can lead to the final answer, which we call a leaf node. Simple as that.
Okay, so here's our game plan. We'll quickly look at the big puzzle. How does a machine even learn? Then we'll uncover the secret sauce, something called recursive partitioning. We'll figure out how it finds the best questions to ask, watch it build a tree piece by piece, and then see how it all comes together.
All right, let's get to the main event. We know what a decision tree looks like, but how does a machine build one? I mean, how does it figure out which questions to ask and what order to ask them in to get to the right answer every time?
Well, it all starts with data. A bunch of it. And it usually looks something like this, just a big table with different features and some final outcome we're trying to predict. Right now, it's just a jumble of information, kind of chaotic. So the real question is, how do we get from this
To this, a clean, organized, and super useful decision tree. How does the machine sift through all that messy data, find the hidden patterns, and turn it into a clear set of rules? The answer is actually a really elegant and simple idea. It's a strategy we humans use all the time when we're facing a complicated problem. We just break it down into smaller, easier to handle pieces. It's the classic divide and conquer approach. In machine learning, this has a name: recursive partitioning. It sounds complex, but it's not. The algorithm takes all the data and just splits it. Then it takes those smaller groups and splits them again and again. It does this recursively, and with each split, it's trying to create groups that are more and more pure, where everything in the group is similar. That's how it builds the tree.
You know, this image of the quicksort algorithm is a perfect way to think about it. The principle is exactly the same. You start with a big, messy deck of cards, you find a smart way to split it into two piles, and then you just keep doing that to the smaller piles. That is precisely how a decision tree gets built, one split at a time.
Okay, so this brings up a really important question. If the whole point is to split the data, how does the algorithm decide how to split it? Out of all the possible questions it could ask, how does it find the absolute best one at each step?
The goal every single time is to make a split that creates the purest possible new groups. And all purity means here is that the groups are as uniform as possible. If you can make a split where one group is all yes answers and the other is all no answers, that's a perfect, pure split.
So how does the algorithm measure this purity? It uses a concept from information theory called entropy. Just think of entropy as a measure of chaos or surprise. A dataset with a total mix of outcomes has high entropy. It's very uncertain. A dataset where almost everything is the same outcome has low entropy. It's very predictable, not much surprise.
So here's the secret. The algorithm literally checks every possible split it could make. For each one, it calculates how much that split would reduce the chaos, or the entropy. That reduction is called information gain. And then it just picks the one split that gives the biggest drop in uncertainty, the highest information gain. It's that simple.
All right, we have all the pieces now: purity, entropy, information gain. So let's see how they all work together to actually build a tree. We're going to watch it happen step by step using a classic example about playing tennis.
Okay, so we start with all our data, 14 days worth of examples. The algorithm calculates the information gain for splitting on every feature: outlook, temperature, humidity, and wind. And it finds that asking about the outlook gives the biggest reduction in uncertainty. So boom, outlook becomes our root node. Now, that first split divides our data into 3 piles. And look, check out that middle branch for overcast. All 4 examples in that group are yes. That means this node is 100% pure. There's no uncertainty left. So the algorithm just stops right there and makes it a yes leaf node. One whole part of our tree is already finished.
But the sunny and rain branches are still mixed up. So what does the algorithm do? It just repeats the whole process on those smaller datasets. For the sunny group, it finds that humidity is the best question to ask next. For the rain group, it's wind. It just keeps doing this, splitting and resplitting until every single path leads to a totally pure leaf node. And just like that, it's done. We've gone from a simple table of observations, and just by repeatedly asking the most informative question, we've created a logical model that can now make predictions on data it's never even seen before. So let's recap that process one more time. It's a really simple recipe. You start with all your data. You find the very best question to ask to maximize your information gain. You split the data based on the answer, and you just repeat that process for each new group over and over until you can't split anymore. It's a top-down, elegant approach.
And this powerful logic is everywhere. Decision trees are used in healthcare to help diagnose patients based on their symptoms. They're used in finance to assess credit risk, in marketing to figure out who to send ads to. In every case, it's about learning the best questions to ask, directly from the data itself.
And that leaves us with a pretty fascinating thought, right? This whole process shows that a machine can learn to build a model that thinks in a very human-like, rule-based way, just by looking at past examples. So as these algorithms get even better, you have to wonder, what complex decisions that we make every single day will be the next to be learned and automated by a machine?